I have only 4 slides, 4 PowerPoint slides. They are very short, okay? My name is Onur Tokeri. I am interested in hardware, software co-design, especially hardware acceleration. And I will just show one example to explain my research area, which is FPGAs and FPGA applications. Here we see a breadboard with lots of cables. Just think about, trying to modify this design or trying to build something similar to this and how difficult it will be if you would like to use cables, lots of components. And this is the third slide. We are coming to the end. Basically, what I would like to mention here is the electronic switch or programmable connection. If you can make the connections programmable, think about programmable breadboard connections. Do you think it will be a good idea? Okay, just try to remember the previous setup and think about all of these connections being programmable. So you don't need to mechanically remove any piece of wire or insert any piece of wire. This will allow us basically build circuits by programming switches rather than playing with wires on a breadboard. That's the main idea of the FPGAs. Basically, FPGAs allow us to build application-specific hardware by programming these switches. No mechanical action. When we look at general-purpose hardware, they are designed to make all potential customers happy. But FPGAs allow basically hardware, software co-design optimized for the specific problem. So you start the design after you learn the problem, but for the general purpose hardware, you do the design before you know the full problem details. You just have some idea about the potential customers, okay? And this is an application where we have the FPGAs used. Basically, when you have when you need high processing power, you have a very short amount of time to process lots of data. In that case, FPGA-based approach turns out to be advantageous. And this is just a short YouTube video which I would like to show you. This is something not so easy to do by using conventional processors. So let's just look at the YouTube video and finish. One minute, okay. I think we are having some technical problems with the, okay. If it starts, I can show you the demo video. So by using 2 camera images, right and left, and by looking at the disparity between the right and left images, you are trying to identify the objects and also measure the depth from the observation point. So here you have single object, but this requires something like this, 3D reconstruction from stereo vision. Stereo camera systems requires really high processing power. And this is something that can be easily achieved by using FPGAs. I hope the idea is clear. This is not a LiDAR-based system, it is just vision-based. Nice.
How's it determining distance?
By looking at the disparity between the right and left.
Oh, it uses two cameras?
Yes, it's using two cameras. Okay.
Okay, I thought it was one camera. I was like, wow, that's cool.
So at the bottom you see the right and the left camera. It's using two. Yes, any questions? Thank you very much.